We're now going to move on to our next presentation today. No, that's not a mistake on our part. Recycling is crossed out for this title. This is Feedstocks for the Next Generation of Products by Karl Englund. Karl works at the Washington State University's Composite Materials and Engineering Center. His research focuses on processing composites and utilizing waste materials as feedstocks. Karl also serves as Chief Technology Officer for Global Fiberglass Solutions, which is a startup manufacturing company focused on recycling wind turbine blades and other glass fiber composites into second-generation products. Karl, it looks like you've got your video on and unmuted, which is great. I think also you might share your screen.
So basically, yeah, as Andy said, I have two appointments. One is a CTO with Global Fiberglass Solutions, where we're recycling fiberglass components. And I also have an appointment as a research prof at Washington State University. And I really I really like how Nicole kind of framed a lot of her talk this morning about, we really need to kind of look at this as not really recycling anymore. It's about really, looking at the next generation of feedstocks. The virgin materials that we have out there that we mine and we drill for, are going to come to some finite end or become more cost prohibitive in the future. But we do have a lot of material that's in our landfills right now, and so I kind of wanted to approach it based upon that. And also, as a faculty member and a person that does a lot of research in recycling with companies and startup, guys either that are doing stuff in their garage or large scale commercial chemical companies or whatever, I've gone through a lot of question and answers with these companies and folks and about how to set up their recycling framework, and a lot of the boxes that you need to check and a lot of the questions that you need answers from are quite similar through a lot of that. And so I'm going to kind of give my perspective on what I think a recycling framework should look like, and some of the basic concepts of a supply value chain of a recycling framework, and then kind of get a little bit more into some, I guess if you want to call it examples kind of thing of looking at glass fiber composites and also carbon fiber composites, which I've done quite a bit of work on in the past also. So I always kind of like to ground everything and kind of bring it back to some focal point, and you always look at, why are we doing what we're doing, and why do we dispose in a landfill? And one of the things that came out of this back in the turn of the century or even earlier than that was that we developed solid waste systems for cleanliness and health, and it was one of the main reasons we did it. And it does a great job at doing that for us now. We also have these things set up to keep them out of the environment, or we try to keep them out of the environment. And our landfills have done a really good job of kind of containing things, but I think we've kind of abused it a little bit at this point in time. And where we really kind of put things in the landfill, as we all know, is that it's lost its value. It's not valuable for us anymore. We throw away our mattress because it's got a divot in it and it gives us a backache. We throw away our TV because it doesn't work anymore. We've lost that value in that product as a consumer for that specific application. And so recycling really needs to kind of go through the process of finding value out of the value list. And so when do we actually start a recycling process? Do we do it for everything all the time? That would be great if we could do that, but I think the science and the technology and the, our logistics don't really allow us to do that, but it's always something that we should be striving for. And one of the things you really have to take in consideration is finding that carbon balance, whether that carbon balance is on an environmental aspect or on a financial aspect, how much carbon, how much energy you're producing in there. That recycling process needs to kind of have that framework installed to balance out all these. You don't want to put a lot of energy into something to recycle something and then end up expending more energy than the actual product itself is worth. And then when do we actually landfill? In some cases, it may be the best option. You get tailings off an MRF facility. There's not a lot you can do with these things, and it may be the best option at this time, but I think what we get from that what we evaluate goes into a landfill is how do we design it the next generation? How do we design for deconstruction? How do we make that plastic more recyclable? How do we make our solid waste system become more robust and be able to take more recycled materials? And so that's kind of like the framework I look at as far as moving forward when I talk to folks that are looking at recycling materials. And when I'm at WSU, I get a lot of folks come with a lot of different materials to say, hey, can I recycle this? And so when you go through that concept, there's a lot of things that I really need to kind of, when I look at talking to somebody or look at helping somebody out with the recycling methods, I really kind of have to go through some of these basic points with them. And the first one, of course, is your process, your method. You need to have a very viable method to recycle. You need to have something, and the viable adverbs are environmentally, economically, socially, all those kind of things that come into play there. That method really needs to kind of make sense in a lot of fronts. And I'll get into these a little bit more on the next couple slides. But the other thing that I think gets overlooked a lot is your feedstock logistics. You need to have, once again, viable transportation. You got to have the right volume, cost, consistency, quality, and those kind of things to really justify the process or method that you're looking at there. And then, of course, a lot of these things are just basic business concepts. But the one thing that you really need to focus on also is that final product needs to compete. It needs to compete in the market that you're looking at. And you don't necessarily have to compete in existing and Me Too replacement markets, but developing new markets and new applications. If you take plastic, for an example, and chemical recycling of plastics, do you have to break that plastic, that nylon, down to its monomeric form and then build it back up? Can you break it down into an oligomer and then sell it as a wax or a surfactant or something like that? And so finding unique and different types of markets and applications is really key, but you can't have inconsistency. You can't have high costs that just make it prohibitive. So if you look at the process itself, you're always going to be looking at cost. And I look at cost a lot of times and I associate carbon or your footprint and dollars a lot of times being very similar in their estimation. And so, you got to keep those costs down. You got to keep the environmental footprint down. You can't put a lot of energy or put a lot of labor into recycling something that is just going to end up costing more, both money and carbon at the end. Your operation and capital costs must be manageable. It must be predictable. You can't have a lot of extreme variances in what your capital is doing in your operation. You got to be able to handle the feedstock coming in, and it's got to be reasonable. The other thing is in a lot of cases, well, 90% of the cases, most people are going to be looking for investors. And will these costs keep your investors comfortable? And will you be able to educate the investors into exactly what you're doing? Some of these product lines that are coming out for recycling are pretty new and innovative areas. And to get an investor educated and informed correctly without preconceived notions that may skew their opinions, that's a very important thing too. The other thing is volume, and I talked about this a little bit more in the feedstock logistics, but your process should really match your volumes. You don't want to develop a process that only works economically or sustainably on a really large volume, and you really don't have that much material there. And on the other side is that, if your process is economically viable and it produces a value-added product, but it only takes 0.1% of the actual volume out there, society and a global perspective, it really doesn't make a big imprint. And so when you look at your process, you really kind of need to also focus in on will I make an impact in this area? The other thing is, and this is really specific to a lot of recycled frameworks, is it robust and flexible? And can you handle a variety of feedstocks at varying compositions? Your process really needs to kind of be able to not take a very finite, very small spectrum of quality you know, the better your process is, the more variety it'll take in. So if you look at feedstock logistics, you know, the basic questions are, you know, what is it? You know, what is it you exactly need? How much are you going to pay for it per pound? And the other thing that a lot of people don't always understand is how is it going to change? And how, you know, if you expand and you go into a larger volume, how is that material going to change? And can your process and can your logistics accommodate for that? You also need to know, you know, how much inventory is actually out there to sustain your process, and how much inventory of that is contaminated, and what contaminants are there, and how can that be overcome. And you really need to kind of normalize and adjust for incoming product variations. And what that means is, as you start to widen out and scale up, and you get more and more product coming in, and you kind of designed it on a very specific product line, you got to be able to normalize. How does your process adjust for these different variations that are coming down the pipe? That's another thing that I think folks don't always kind of think about ahead of time, is once they kind of deplete this supply chain, or this supply chain kind of moves to a different composition, how do I adjust for that? And then also locating your facility, you need to have pathways to the site. You need to have transportation logistics set up so that you can get material to it. You got to have access to assets. You got to have access to human capital, folks that can work your facility and be there, and be able to get the material to you at the right way. And then transportation logistics is really just, you know, can I put it on a barge to cheapen it up, or can I put it on a rail, or does everything have to be on truck kind of thing? And then product performance, you know, these are the basic ones here. You know, it's got to be cost competitive, quality, consistent, reliable, all those kind of things that you see, competitive, marketed. But one of the things I think is really big in the recycling world is not, you can't solely rely on recycled products as a marketing strategy. And sometimes in some sectors, if you look at a recycled product, they look at it more as an inferior product, and sometimes it's not always the best thing to put out there. And so you really have to have a product that is viable in a lot of different scenarios there. So, so one of the things that I want to take a look at here was that's really near and dear to my heart is looking at recycling glass fiber composites and carbon fiber composites. Both of these are very difficult. They use a thermoset resin predominantly in there that makes them not recyclable very easily. The thing is, the difference between these two segments is pretty stark. You know, glass fiber composites are everywhere. I mean, there's huge volumes. They're in all, you know, cars that we have nowadays, the truck and trailers that you see out there, your RVs, the wind turbine blades that I'll talk about a little bit more. These are pretty, you know, pronounced items that are throughout our culture and throughout our society that really don't have a whole lot of value once they're done. And one of the problems is the fiber itself, glass fiber, is pretty low value fiber. Whereas with carbon fiber, you know, there's a lot lower volumes, but the fiber is a lot higher value. It's thought after it's about 7 to 10 times more expensive for carbon fiber. And so if you look at some of the recycling strategies that are going on right now, a lot of them will look at a chemical or thermal methodology to liberate the fiber. So they take that resin that you see there that holds the fibers together and get rid of that resin, and then liberate and get back to the original carbon or glass fiber. And the other way of doing it is mechanical, is where you break it down and you turn into a source of material that you can use for later on. So if you look at the example of wind turbine blades, working with Global Fiberglass Solutions, or GFS, you know, we've looked at this as a really big volume that needs to be serviced and recycled. You know, there's over 60,000 turbines out there, about 1.4 million tons of blades in service right now. The average life is 15, 20 years. But if you look at the graph at the bottom there, you know, the wind energy is actually a pretty small chunk of that pie of the global glass fiber composite market. And so we look at this as being, yeah, we're going after wind turbine blades, but there's also a lot of other materials out there. And so we're looking at a really high volume that needs to be processed. We're keeping our processing costs down. But one of the things that really needs to be kind of put in perspective is building that supply chain. You know, you can't really go out and get a go on Craigslist or Alibaba and find, you know, wind turbine blades that are ready to be recycled. It's one of those things you have to build that supply chain. And that's one of the things that we've had to do at GFS. You know, I always kind of put it in, you know, in the similarity or comparison to the forest products industry, where you have a forest that you have silviculturists go out and tell you how much is out there. You have loggers that cut them down, and transportation trucking system that goes and process or brings them to the processing plant. You have guys that make 2x4s out of it, or they make paper, or the secondary manufacturing scraps go into a panel product or a panel board. All these different parts of this supply chain or value chain have lots of different entities in there. You know, the person that's making a panel product doesn't have anything really to do with the sawmill and the logging side of it. So one of the things with looking at newer materials and new products like this is dealing with this supply chain. And at GFS, we've had to deal with that entire supply chain there, and dealing with working with the vendors and the owners and the operators of the wind farms, and getting the blades, getting onto their vendor contract list is a big hurdle to even come over with that. And then transportation, you know, do you put it on truck, do you put it on rail, how do you get it to our manufacturing site, and then product sales and that kind of stuff. So we've had to kind of look at a pretty big bite for a startup company to really kind of take on that entire supply chain. And that becomes pretty daunting.
And Carl, this is your 2-minute warning.
2-minute warning. All right, I'll run through this really quick. So basically what we do, we break down the product. We don't try to liberate the fiber out of that. We kind of break it down into a furnish, that we call it, that looks like what you would see in a fiberboard plant, where you make a composite panel out of it. You know, pros on it, we can take a high value out of it. We get some really nice products out of there that fit into a market, that make the economics work. The problems with it, like I said, no existing supply chain. The capital costs are pretty high, not too high, but they definitely, you know, make investors look twice at it. And it's new, it's different, and those are the things that we need to overcome. If you look at carbon fiber, you know, a lot of the folks that are doing it now commercially is a thermal breakdown, where they liberate the fiber and turn it into a second generation product there. It's a lot smaller volume, once again, but it really kind of addresses the fact that you can get more money out of that glass fiber as an individual fiber. And so a lot of the current commercial folks working on that do this kind of process. And so if you look at the difference there, you know, carbon fiber is quite a bit more expensive, so it's a little bit easier to justify that recycling on there. But volume glass fiber is quite a bit more in volume. It's everywhere. And so there's a real societal need to recycle. And with GFS, you know, we're addressing these really large volumes and all the other stuff that's out there, the cost and competitiveness and all that kind of stuff. But in both cases, you know, the logistics, developing that supply chain and developing that mentality that these things aren't just waste materials, really kind of is something that both sides of this really need to do. So hopefully that's quick enough there. If you guys want to contact me, you can contact me either both emails at either Global Fiberglass or WSU. And really sorry about the slide presentation there. So thanks.